Today we'll start with lesson 2, which deal mostly with solution and standard solution and dilution and all that stuff. However, more lab things that we have to do, and it's easier in comparison to lesson 1. So, what do we have in a lesson? In the lesson 1, we dealt with all those concentration in industry, concentration in molar concentration, and all the ion concentration and all that stuff. Now this is in a lab setting when we are, the job is to create a standard solution. When we create a standard solution, what we do is we create a stock solution. A stock solution from a solid mass. And the mass is in grams. So let's see now, determine the mass that is needed for the ammonium sulfate to make 100 milliliters of a concentration of 0.500 molarity. So what we are looking for is the mass of ammonium sulfate. So then we start with 100 milliliters or 0.100 liters, okay, times, and now we have the molarity. So 0.500 molarity means that in 1 liter, what do we have is 0.500 moles, or if we are diluting 0.500 moles in 1 liter, then we will have the molarity of 0.500. So now that means that we will have two ratios, the ratio 1 and the ratio 2. In order to cancel the liters that are in the numerator, what do we have to do is we have to multiply by ratio 2. So then we go 1 liter, and on the top 0.500 moles. What do we have up to now? So liters and liters are canceled. What do we have up to now is moles. So then what do we have to do in order to find the grams? Because what is the mass? When we are saying mass is grams, then we have to find the molar mass. Okay, so the molar mass of ammonium sulfate having two nitrogen and 8 hydrogen and 1 sulfur and 4 oxygen. Using the calculator or the data booklet that you have in possession will be 137.17 grams per mole. The meaning of this number is that if you have 137.17 grams of ammonium sulfate, then you have 1 mole of ammonium sulfate. Or in 1 mole of ammonium sulfate, you will have 137.17 grams of ammonium sulfate. So that means that you have two ratios, the ratio 1 and the ratio 2. Now, in order to have the grams, to figure out what is the grams, because now what we have now is moles, we have to multiply it with ratio 1. So then it is 1 mole in the bottom of ammonium sulfate is 137.17 grams of ammonium sulfate. So moles and moles are canceled out. And what do you have now in terms of the units is grams, and this is what we were looking for. Now in your calculator, 0.100 times 0.500 times 137.17 will be 6.89 grams of ammonium, 86, not 89, 86 grams of ammonium sulfate are needed to be mixed into the 100 milliliters of a solution. okay, to create a solution of 0.500 molarity. Let's see now the second example. We have sodium sulfate. Okay, so now you always, when you're doing something like this, what you're doing is you're starting with what they are giving you. Okay, start with something that they are giving you. And on those cases, since it is, we have on molarity, we have a ratio. In order to decide which ratio are you using, moles per liters or liters per moles, do not memorize it. I don't suggest to memorize it. In order to decide using your logic which ratio are you using, I will say start with liters. So with volume. So now on this case, you will go 0.500 liters times. Now here you will use the molarity ratio, I will say. And then what do you have here is you will end up with moles. Now, in order to figure out grams, use molar mass. And then you will have grams. If you go through those calculations, then you should have 107 grams. You try this on your own. Okay. Now, in this video, you cannot see the link on the video, but on the digital notebook, you are able to see the link for the video. Just look at that video and then create a procedure using those 1 to 6 numbers. If you want the answer for the procedure that you have to follow on the preparing the stock solution, I will just give it to you now before I start dilution. As the first step is 4. So weigh out the mass of the compound and then dissolve the compound in water with stir stick. And then you transfer the volumetric flask with funnel. And then number 5 will be rinse the beaker. Number 3 will be add water until meniscus reaches line and then rinse the flask. Those will be the steps. So 4, 2, 6, 5, 3, 1. And now when we are talking about dilution, then what we are doing is we have to consider that if a solution is with a molarity of 0.1 or less, is considered to be diluted solutions. And if they have a molarity of 1, then or higher, they are considered to be concentrated. The equation for the dilution is C1V1 is equal to C2V2, where C is the concentration of the initial, V is the volume of initial, C2 is the concentration of the final, and V2 is the volume of the final. Let's see some examples here into when we are working with the dilution. So water is added to 0.200 liters of 2.4 moles per liter molarity ammonium cleaning solution until the final volume is 1.0 liter. Find the amount of the concentrated diluted solution. So what is the concentration on the second one? So what do we have here is C1 is equal to 0.2, sorry, V1, not C1. V1 is is V1 is 0.200 liters, C1 is 2.4 moles per liter, and then the final volume, so V2 is 1.0 liter, and we are looking for C2. So if we refer to the equation here, the dilution equation, C1 V1 equals to C2 V2, then we can solve for C2 as being C1 V1 over V2. So in this case, it will be C2, which is the concentration of the diluted solution, will be 2.4 moles per liter times 0.200 liters, the whole thing over 1.0 liters. So liters and liters is canceled out. And then we have as the concentration of 0.480 moles per liter, or you can say molarity, just M. Okay. Next example is a 1.220 solution of potassium carbonate has a concentration of 0.460 moles per liter. What is the concentration of the stock if 20 milliliter were used to make the diluted solution? So now what we have here is that the stock solution is the initial, okay? Initial either volume or concentration, okay? Because we create a stock solution, as we said in the first few minutes of this video, we create the stock solution, and then from there we take and dilute the solution. Okay, so now what we have here is we don't know what the concentration of the stock solution is, but what we are taking from that stock solution is 20 milliliters, and now the diluted solution has a concentration of 0.460. You can say just M or moles per liters is the same thing. And what your volume of the diluted solution is 1.20 liters. And just so that you can see that it is cancel out, milliliters and milliliters is cancel out, then you can convert it into milliliters. So see now what do we have? The formula is C1 V1 equals C2 V2. We are looking for C1. We know everything else. We know what V1, C2, V2 are. So then from here we can say that C1 is equal to C2 V2 over V1, and now the units of volume are the same, and then you will see that will cancel out, so it will be 0.460 molarity times V2 is 200 milliliters over 20 milliliters. So milliliters and milliliters are canceled out, and then we have a concentration of the stock solution, or the initial one, as 27.6 molarity, or you can say 27.6 moles per liter. Okay. Let's take a look now to the third example here. When we have a 340 milliliter solution has a concentration of 0.4. So volume 1 is equal to 340 milliliters. C1 is equal to 0.470 molarity, or moles per liter is the same thing. We are looking for what is the concentration of is going to be if volume 2 is 290 milliliters. So you are adding more water into it, but you are adding into the original volume, which is 340 milliliters. So the total volume after you are adding 290 milliliters of water will be 630 milliliters. So now we start with the formula C1V1 dilution formula, C2V2, and we are looking for C2, which will be C1V1 over V2. So C1 is 0.470 molarity, V1 is 340 milliliters over V2 after you are adding 290 milliliters of water will be 630 milliliters. So milliliters and milliliters are cancelled out, and then you will have a concentration of 0.254 molarity after you are adding it. Okay. We talked about solubility. And solubility, when we are talking about solubility, we are usually referring to the information that we have on page 6 of our data booklet. However, there is way more on solubility, and one of the factors that affects solubility very often for different compounds is the temperature. And this is a graph showing what is the effect that the temperature has on different type of solids. So in this case, we have a solid A that is following this line here. We have a solid B, so like a compound B, and we have a compound C that is following this line. As you see here, we can say that compound C doesn't have any effect in the solubility of the temperature. So as the temperature is increased, the solubility of compound C is not changing at all, is the same. Okay, so we have about 38 grams per 100 grams of water. So the solubility doesn't change, always will be this. You will add 38 grams of solid C into 100 grams of water, and this with increase of the temperature will not change. But when we take a look at A and B, we will notice that the solubility changes as the temperature is increased. So what this is saying that, let's say at 40 degrees Celsius for for A, what you will have, what you can dissolve into A is about 60 grams in 100 grams of water. But for B, at 40 degrees, what you can, when you can dissolve is about 70 grams at 40 degrees Celsius. And then as the temperature changes, the amount that you can mix with 100 grams of water, it is changing. And you notice here that at this point here, which is about 52 degrees, at 52 degrees, the amount that you can add into 100 grams of water for both A and B is the same, and it's about 78 grams. Now let's see, and this is all about reading the graph, the solubility graph, and knowing the effect that the temperature has into how much you can add into a certain amount of water. Now, which compound has a higher solubility at 40 degrees? So we can say that when we go at 40 degrees, then we see that solid B has a higher amount than solid A that is following this line here. So this is A and this is B. So B is having about, what is this? Probably 70 grams in 100 grams of water, while A is having 60 grams. So we can say that the higher solubility at 40 degrees Celsius is B. And which one has a higher at 70 degrees Celsius? So we go to 70 degrees Celsius, and then we see that solid C doesn't have any effect. It's the same. And then for B, what do we have is about this one here. For B, what do we have? I will write it here so that you can see. Is, I will say, 96 grams per 100 grams of water. And for A, I will use a different color so that you can see. For A, what do we have? Is this one here. So for A, we have 122 grams per 100 grams of water. So as you see here at 70 degrees, solid A kind of take the power, and you can add more at 70 degrees Celsius. This graph here is it's more complex because we have more compounds that we are dealing with, and then we are looking at the solubility that they have at different temperature. So now, when we are looking at solubility of ammonium chloride at 60 degrees Celsius, so we will go to 60 degrees Celsius. This is what the temperature is asking for. And then we will find the ammonium chloride. So ammonium chloride is chloride is NH4Cl. Okay, so we'll go to 60 degrees, and then we will reach NH4Cl, and we will go horizontally. So this being the first step, and then horizontally being the second step, and then we can say that it's about 55 grams per 100 grams of water. So 55 grams per 100 grams of H2O. Okay. Next one is solubility of potassium nitrate at 70 degrees Celsius. I will change the color here. So potassium nitrate is this one, KNO3, and we are looking at 70 degrees Celsius. So we will go 70 degrees Celsius from vertically up until it reaches the potassium. This will be the first step, potassium nitrate, and then we will go horizontally, this being the second step, and take the reading from here. So we can say that potassium nitrate has a solubility of 130 grams per 100 grams of water. And now, would 30 grams of potassium nitrate fully dissolve at 10 degrees Celsius? Okay, so now let's see. Potassium nitrate is KNO3. Okay, now we will go to the 30 grams. So 30 grams is somewhere in here. And then we will see what is the temperature that this is fully dissolved. So will be something like this being the second step, will be something as 18 degrees, which is greater than 10 degrees Celsius. So you can say no, because the maximum that KNO3 can dissolve at 10 degrees Celsius is way lower than 30, which is about 22. Maximum that KNO3 maximum at 10 degrees Celsius is 22 grams per 100 grams of water. Which compound experience the least amount of change? The one that has the most flat line, and it is table salt. Which compound experienced the most amount of change? It's the one that has the steepest line, and when you see here, the steepest line is KNO3. NO3. What would happen? What would happen if more than 100 grams of KNO3 was added to 50 degrees Celsius? So now if we go to KNO3, we have 50 degrees Celsius, then it will not dissolve. So we'll dissolve at 50 degrees Celsius, we'll dissolve 80, and if you are having 20, then 20% will not dissolve, so will be a saturated solution. So it will not dissolve. We'll be able to dissolve only 80 grams. The rest will be not dissolved, will be excess. Okay, so 50 milliliters at 30 degrees Celsius make a saturated solution of sodium sulfate. If this solution is evaporated to dryness, and 46.4 grams of sodium sulfate decahydrate crystallize, what is the solubility of sodium sulfate decahydrate at 30 degrees Celsius. Okay, so now what you have is that you have 46.4 grams of sodium sulfate decahydrate into 50 milliliters of water at 30 degrees Celsius. Now, always when we are measuring solubility, we make it what is the grams that is mixed with, is soluble at, in 100 milliliters of water. So this is X, and then that means that you cross multiply two that you know, so X will be 100 milliliters times 46.4 grams over 50 milliliters. So milliliters and milliliters is canceled out, and then you will have 92.8 grams of sodium sulfate decahydrate in 100 grams of water, which is the same as saying 100 milliliters. Now, what we have here is that on the second example, 40 grams of potassium chloride will dissolve in 200 milliliters of solution at 40 degrees. What is the solubility of potassium chloride? Again, what we are doing is that in 200 milliliters, but in order to measure the solubility, we have to have 100 milliliters. So this is X, and then from here, X will be equals to 20 grams of potassium chloride in 100 milliliters or grams of water. Because for water, what do we say? Grams and milliliters is pretty much the same. And now what we have here is 42.0 grams of sodium iodine will dissolve in 60 milliliters at 40 degrees. What is the solubility? This is, again, this is easy because 42 grams on 60 milliliters, but we want it to be in 100 milliliters on X, and this will be 100 milliliters times 42.0 grams over 60 milliliters. And then from here you can find that solubility at 40 degrees for sodium iodine is 24.0 grams in 100 grams of water. Now you can move to assignment. You can complete the assignment 2, and then we will see and move to, be ready for the quiz, because this is the end of solution part of the unit, and be ready for the quiz.